Hey there. So moving through this unit of work, I want you to become really conscious of being both clear and efficient in your working. At the moment we're working with composite shapes, but you're going to be moving into composite solids and surface area of composite solids where you're going to have up to 10 pieces of information that you're adding up. And it's really easy for you to get lost, but also for the person who's reading it to get lost. I guess you have to keep in mind that even though while you were doing the problem, you knew what you were calculating, if you came back to it later or if someone else was trying to read it, they're not a mind reader and they need to know step by step exactly what you were thinking. Okay, so I'll show you this with this example. We've got this cone shape, and when I first look at it, I notice I have three sort of clear spaces. I have the left triangle, the right triangle, and this top half a circle. Now I want to find the area of this composite shape. So I'm going to start by saying the area total, using a capital T for total. Now I have to make a decision. Well, how am I going to split this up? Clearly I've got a half a circle, so I'm going to start with that. The area of half a circle. Okay, and I'm going to add to it. Now I did see two shapes, but it would be less efficient if I calculated them separately than if I calculated them as one whole shape. So I'm going to calculate it as one whole triangle. And notice that my little mini shapes here are like icons, and they come directly from this original shape. And that way whoever's looking at it can clearly see this relates to this, this relates to this, okay? It's really visually obvious. Alright, so then we substitute in some formulas. Now we know area of a circle, a whole circle, is pi r squared. But we're only looking at half a circle, so we're just going to divide it by 2. I'm going to do that quite easily and efficiently in here. Area of a triangle is always base height over 2. Then I can substitute in pi. Radius of this is from the centre all the way out, which is 8 squared all over 2, plus base of this triangle is this whole long base 16 times the height, which is 15 over 2. I'll just pause there for a moment. You'll notice that this 17 centimetres has not been used in any part of the calculation. It's actually a redundant piece of information in the original picture. It's not necessary for me to calculate the area. So don't worry, don't panic if you haven't used everything in a picture. Now, pi times 8 squared, 64 on 2, is the same as 32 pi. I'm just keeping that pi there for now. There's no need to round until the very end. 16 times 15 on 2. Well, I'm going to make that 8 times 15, okay, which is 100 and... Hang on, I just went a little bit blank then. 120. At this point, because I want to find an area clearly, I'm going to use my calculator. So 32 times pi plus 120 is equal to 220.53 centimetres squared, because I'm looking at area, to 2 decimal places. And hopefully you can see it's been really efficient and really clear. I've kept everything here on the left, I've kept everything here on the right. I've only rounded at the very last moment to keep it as accurate as I can.